Consider the equilibrium N2 plus O2 plus Br2 to NOBr. Calculate the Kp for this reaction. So Kp equals, we don't know, given the following information. So we're given two reactions with their corresponding Kcs, and then we are to get the Kp for a required reaction. So this is the required reaction. So we are given two equations. Equation 1, 2NO plus Br2 2NOBr, and the Kc for this reaction is 2.0. And then we're given another reaction with the equation, this is the second one, 2NO and 2 plus O2. And the Kc for this is 2.1 times 10 to the 30. Okay, so how do we get the Kp of the required reaction from the two equations? So we got to have a plan. What is our plan? Number 1, solve for Kp for the required reaction. And how do we do that? If you look at the two equations, if you look at the original equation, the N2 and the O2 are on the left side, and if you look at equation 2, the N2 and the O2 are on the right side. So it looks like we have to reverse equation 2. After we've reversed equation 2, what we do next is we need to add the result in step 1a to equation 1, and then we solve for Kp. Solve for Kp, and then once we have a Kp, use Kp is equal to Kc times RT delta N to solve for Kc. Solve for Kc. Okay, so that is our plan of attack. So now let's execute. So step 1a. Step 1a, reverse equation 2. So when we reverse equation 2, it becomes N2 gas plus O2 gas. You produce 2NO gas. The resulting Kc, since we reversed it, the resulting Kc would be the reciprocal of the forward Kc. It's 1 over 2.1 times 10 to the 30, and that would be 4.76 times 10 to the negative 31. Okay, step 1b. Step 1b. Add the result in step 1 to equation 1. So we rewrite equation 1, 2NO gas plus Br2 gas, 2NOBr gas. We didn't do anything to the equation, we just rewrote it so the Kc stays the same. It's L 2.0. Okay, so we need to add these two equations. So we have the terms on the left side. You have N2 plus O2 plus 2NO plus Br2, and the terms on the right side are 2NO plus 2NOBr. Yes. Okay, so 2NO is common to both sides, so we get rid of the 2NO. So our resulting equation now becomes N2 plus O2 plus Br2, and on the right side we just have 2NOBr. Notice that this here is our target equation, isn't it? So yeah, since we added the two equations, our resulting Kp or Kc is the product of the two Kc's. That's 4.76 times 10 to the negative 31 times 2.0. So you should get 9.52 times 10 to the negative 31. Alright, so this is Kc. So that's step 1c. Kc. Next, step 2. Step 2, use Kp equals Kc times RT delta N, solve for Kc. So Kp is equal to Kc times RT delta N. We plug in the values. This would be 9.52 times 10 to the negative 31 times R is 0.0821, and the temperature is 298 times 298. Delta N is products minus reactants, so the delta N is equal to just 2. The coefficient is 2 minus the sum of the coefficients of the reactants is 1 plus 1 plus 1 and 2, 1 O2 and 1 Br2. So delta N is 2 minus 3 is negative 1. So Kp is equal to 9.52 times 10 to the, I'm sorry, this now is raised to the negative 1. Alright, so the answer then, Kp is equal to 3.89 times 10 to the negative 32.